And welcome. My video didn't work this time. So we have episode 72 of Quarkus Insights, and we got guests this time, and we have news actually. One small news is that George actually now is a parent, and he just got a son. Sorry, daughter. I forgot.
Son.
It was son. Yes. I was like, wait, I didn't check. Anyway, so he's
two.
Well, one's enough.
Yeah. No, so George is here. This is his paternity leave, is being on Quarkus Insights. That's the the relaxations. And we got a Quarkus 2.5 released last week, which actually had quite a bits of news. Just skimming down the list here. We updated Graal VM. We got a JPA into listeners in Hibernate, which is good. The Quarkus header, I see that. Do you guys know what that one is? The Quarkus HTTP header?
Yeah, you can configure, basically you can just add a property to application properties, and then I think every response will contain a header. George Gastaldi had some kind of use case for this. I don't really remember.
But it's like a fixed set of headers. Do you always want to
Yeah, exactly.
Okay.
So if you want to add your vendor name or whatever, or even your API version, you can do that. You just configure it, and all your responses will contain
that works across the entire HTTP stack. So that's pretty cool.
Cool. But it's server-side header, not client.
Yes.
On client side, in the previous version, we also added something similar where you can pass a fixed set of headers to all the requests for a specific endpoint.
Cool.
Like your key or something like that.
And then we got security, which is all about GitHub and LinkedIn. That's going to be fun because I know Steph was having fun last week about that one. So, but that's good. Like it's always painful to deal with that one. So that's added in. Let's see, Reactive Microsoft SQL Server Client. Support encryption. Okay, cool. We can now be safe.
And you also have the dev service.
There's a dev service?
Yes.
Cool. That was missing in the release notes.
Maybe it was before,
but InfiniSpan, a dev service for Oracle. Start your Oracle database.
Yep.
In dev and test mode. I thought that was that's good. So that's been waiting for a long time. We had support for Oracle, but not because they didn't have a reliable docs issue. But now it's there.
They didn't have a container that starts in a reasonable amount of time.
Yeah.
So now they provide one. So it's pretty good for us because you can actually develop your application against a real Oracle instance and go to production against a real Oracle instance, and that reduces the difference between your dev and your prod.
And we got updates to Camel. The community extension now has service binding support. That's not true. It had service binding support before. It could read the metadata that the service binding spec gives you. But now also when you actually are requiring, I think it's Postgres, then we will create a service binding for you when you deploy via Kubernetes. And I think that list is going to be expanding over time.
Right, yeah.
But the big deal here is that we've had Kubernetes for years, and there's never been like a consistent way of how services could register each other. Client could find services. But a service binding spec kind of try and solve that. But it requires yet a piece of YAML that is a bit like, hey, I already know what it is. And Quarkus says, well, hey, if you let us do it, we will do it for you. But of course, you can still, if you want to do YAML by hand or have some other process, you can do that too. This is just kind of like, hey, we have a 90% chance of this being correct. Let's put it in, and you can apply it or you can modify it. And then there's a fun one. I actually surprised this took. We have Quarkus Maven plugin offline. So I forgot what the use case came in. There's a customer who he wanted to make sure he had all the dependencies down because he could be at home, have full access to the internet, but when he get to the office, then it was a new version, he had to go to a different like IT to get the latest whatever. So he just wanted to get everything down and then deal with IT later, kind of thing. So he used Maven Go Offline, and that unfortunately doesn't get all dependencies because Quarkus has a build time phase where it goes and gets other part pieces that Maven didn't know about. And you can ask, like, why don't you let Maven know? Well, if we did that, we will be even slower in normal case. So anyway, what we've done now is we added a Go Offline tool that you can add. So you can just say, hey, please give me all dependencies that you would use besides the one that are there for compile time. So yeah, I think that was a big thing. So that was a bit of everything in that 2.5. So that's good.
Yeah, it's pretty big.
Yeah. Oh, and then there was something else too. Sorry, there's 3 news. We got a baby, we got a release, and we got a book. Clement. There we
Brand
go.
new,
Reactive System in Java.
hot off the press.
Yeah.
And
Published last Wednesday, so on the 23rd. Reactive systems in Java that I co-wrote with Ken Finnegan. It covered, well, a lot of things in Quarkus 2.4, 2.5, so it's already covering 2.5. So REST easy reactive, Hibernate reactive, reactive messaging, so the topic of today. Why we did it that way, how do we integrate reactive inside Quarkus, what does that mean for you, and we even go further with things like Debezium, IMQP, Kafka, of course, observability with OpenTelemetry and things like that.
awesome. So no, I should read that too. Can I get a copy?
If you order it now, you may have it for Christmas.
Got it. Okay.
Is there a Black Friday deal or?
I'm not sure. Actually, I was pinged on Friday that it's out of stock in France, so I don't know in Switzerland, Greece, and UK.
Okay,
maybe
so
you're lucky.
Your parents and family ordered all the books. That's what you.
Yeah, you bought them
I'm not sure.
Oh.
I believe they just ordered a few of them, so that's why it's quickly out of stock.
Awesome. No, that's great. That's awesome. And actually, we have quite a, like, if you go on Quarkus.io/books, I think you'll actually you're getting a lot of books actually. Like,
Oh yeah, we have
7
a ton.
or 8.
Yeah.
So.
But this one's the best one.
At least it's the most recent one, which covered Quarkus 2.4, 2.5.
Awesome. Okay, so anyway, we'll get to Ozan in 2 seconds. I'll just say, like, as always, we have a subject this time, topic, Reactive Messaging Kafka, which we've been wanting to do for a few, like, months, I guess. But now we finally have it. If anyone has questions that are listening on Twitter and Facebook and Twitch and wherever else we go, or YouTube, just put the questions in the chat and we will relay it once we find a good time to do so. But yeah, I always find like getting questions from the audience is funnier than whatever we make up. So anyway, but Ozan, introduce yourself. How do you get here?
Yeah, so my name is Ozan Günalp, and I work for Red Hat in small reactive messaging and Quarkus projects. And I've been there for 6 months now, so my knowledge on the subject is somewhat limited. So if you have any advanced questions, I guess some of the other guys can respond to it.
Well, here we have an author, so if someone wrote a book, it might help.
Yeah, maybe.
You know enough, Ozan, so yeah.
So other than that, I don't know what to say about myself. Previously, I was living in France, now in London. I have a PhD in computer science on everything IoT, and back then we called it pervasive computing.
Cool.
And I worked a bit on OSGI as well. Now working on Quarkus. Yeah.
Clement loves OSGI.
Well,
love and hate relationship, let's say.
Yeah, it's a complicated relationship.
Yeah, I know.
Yeah.
I know. All right. Anyway, Ozan, what do you want to talk about today?
Well, reactive messaging and Kafka and its support on Quarkus. Let's start by maybe reactive messaging, right? Reactive messaging is a microprofile specification. The implementation that we are using and working on is Mora reactive messaging. And it is a framework for building event-driven applications, such as like data streaming or event sourcing and data processing. And the implementation that we are using and developing this Morai runs and builds on this same reactive programming library as of Quarkus, so Mutiny. And hopefully today we are going to show some of the integrations that we have on Quarkus and some of the other reactive extensions, such as REST Easy Reactive and Hibernate Reactive, etc. And I have kind of a demo. We will develop a demo application that I started, and we will develop together. And what else I can say about reactive messaging? And maybe I can say some things about Kafka, because reactive messaging is a generic framework in which everything runs on a notion called channels, and you can actually connect different messaging backends, messaging technologies into the channels. And one of the technologies is Kafka. We support it. The other ones are AMQP, MQTT, RabbitMQ, Camel, and all of those have Quarkus extensions as well. So it pulls down the connector that we are talking about. For this instance, is Kafka, and Quarkus adds up some things to run natively on GraalVM, or do some configuration stuff that makes life easier, and also proposes dev services, at least for Kafka and RabbitMQ.
So the reactive messaging part is a client? It's just
reactive messaging is a framework. It's a separate library, and it implements the microprofile specification. So you can use small reactive messaging without Quarkus. It builds on CDI specification, so you still need some container platform. Not like a container Docker, but container context and dependency integration. So other than that, in Quarkus, we integrate it and help on the configuration side and dev services and running on native, etc.
Cool.
So just for the Spring folks out there, this is similar to what Spring Cloud Stream looks like, right?
Yeah.
Yeah, it's relatively close, except that, well, reactive messaging is based on CDI. But the idea to provide a stream-based or event-based development model is the same, yes. Mm-hmm. And you will find similar concept, like the channel concepts is something that Spring Cloud Streams has, or something like this.
Well, it's messaging. Channels is kind of like, that's what it does, right?
So it's messaging and plus, so you can connect to brokers such as MQP, MQTT, or Kafka. You can also use HTTP or WebSockets, which are not broker per se, but you can receive from HTTP, send through WebSockets, and you can also connect to with Camel. So basically, you can literally interact with anything that exists today, thanks to the Camel connectors and Camel extensions. And so you can read from Camel and write to Camel routes, and that make it very adaptable to almost anything that we have.
What do you read and write to a Camel route?
You read from, so Camel will give you things you will process things and you will write
things. Got it. Okay.
So, but yeah, in that case, you need to know what you will get in and what you want to write out.
Sure. All right. Cool. You want to show some code?
Yeah, why not? Let's see.
Share
I'm going to share my screen. Hopefully, everybody. Is it visible? I'm guessing so.
Yeah.
Yeah.
Let's see something.
So what I have,
Maybe a little bigger, but
like that.
Good.
yeah.
I actually couldn't find how to get the terminal bigger, and I wanted to have it in IDE because.
Well, this is IntelliJ, right?
Yeah.
Okay, so if you go to File, Settings,
Yeah.
I think it should be Appearance. Go to the first one, Appearance. Well, it has a custom font.
This is the
Okay,
presentation
so
mode.
let me. I'll find it.
Let me
Okay,
see
no.
if I
Okay,
can
so if you
do
go
that.
to Editor, actually not Appearance. If you go to Editor,
Yeah.
and then you go to Font,
Yeah.
there you could change it.
Let's see.
It should change it to
Oh,
yeah.
great.
Yeah, there you go. Awesome.
Maybe do 22.
Excellent.
Yeah, perfect.
Okay. So what I have here is a project created from scratch using Quarkus CLI. So I did a create app with a bunch of extensions to start with. I have REST Easy Reactive, REST Easy Reactive Jackson, small reactive messaging Kafka, and Epicuria registry Avro. To give an introduction for Epicuria registry, it's a schema registry implementation. And for this extension, it configures also Avro to use as a serializer, deserializer schemas as Avro schemas.
Yeah, and
I have
Avro is the serialization. Is it protocol for Kafka or is it just format? I forgot what it was.
It is a format, and Kafka serializers, deserializers can use Avro. And Epicuria actually proposes serializers, deserializers for Avro.
So when you use some as well. When you use Kafka, you can decide what kind of serialization you want to provide, you want to use. Most of the time, you just use JSON or something like that. That's what a lot of people are using. Quarkus supports it, so no problem with that. However, if your application is a little bit big, or if you need to exchange things with other parts, other departments, other teams, I would heavily recommend to use a schema-based serialization like Avro, where you can have versions, when you can have, schema updates and things like that. And in that case, you have a schema registry somewhere, you write your schema there, and what Kafka is going to do is just retrieving the schema and validating that what you get is what you expect, and what you write is what you need to write.
Got it. Okay.
Yeah. So you can define backward and forward compatible schemas, and actually your consumers and producers for Kafka will be using the same schema that is registered onto the schema registry. And we're going to see that briefly, I think, not deep dive on Avro in this time. So I guess that's all I have in the dependencies.
And also, just came a question from Nick there. In a two-part, in a given service, I might use Kafka in several different ways. I might log to one topic, read my event source topic from start and startup, and consume a command topic from the last. Oh, that's a long sentence from the last offset. And then his question is just how well does reactive messaging play with very niche across different topics? So this is
let me
like
see the first part of the question. So
I have it under my. Well, I can read it, so I'm going to answer. That's easier. So basically, you will have several channels, one per topic or one per way to consume your topic, and you will configure them differently.
Multiple channels could use the same topic.
Yes, they can use the same topics. They will just have different names inside your application, but they can target the same topic. Yes, so you can have one that seek from the first offset, one that just takes the latest ones. There's no problem with this.
All right. So basically, the answer is it works. Oh, it works well.
So back to the application that we are going to develop. So the idea is to gather the clicks from a web page and actually capture the clicks of a user and push them to Kafka and do some aggregation, some persistence, etc. And let me jump into. I showed you the click record, the arrow schema that we are going to push to Kafka. So it has a user ID and XPath, which is the element that was clicked on the web page, right? And I have a clicks resource. Sorry?
I was just saying yes. So we are spying on the user. That's good.
Yeah, more or less. Yeah. So I have a REST easy endpoint which will receive the post requests, and for now just log into the console. Let me start my application on dev mode. Again, just to remind, I have REST easy reactive, small reactive messaging Kafka, and a Epicura registry for our extensions. So that will give me, as far as dev services, a couple of containers that are already started with my application. So I have a Epicura registry and Red Panda, which is a C++ implementation for implementing Kafka API. Is that correct, Clement?
It's a Kafka protocol. It's an implementation of the Kafka protocol.
Protocol, exactly. So now, first of all, let me check if I have the Epicura Panda.
And just while you're talking or showing us, I just want to, for those who might not know, dev services is it's not new anymore, but maybe people haven't tried it yet. So it's just, if you have a configuration where you do not configure your connection, like your Postgres or your Kafka or your something, Quarkus will assume you want it and start up a container that is actually the exact same thing or something very close by, which is in this case, we are using the Red Panda. You might be targeting, a traditional Kafka instead, but Red Panda has the advantage of it being a bit, not even a bit, a lot faster to start up.
Yeah.
That's kind of the thing we do here.
And there is work in progress to get a proper or real Kafka broker instead of Red Panda, or in addition to Red Panda, hopefully before the end of this year.
Yeah.
Work has started. We're just waiting for releases to happen and then integration.
That's be there. Yeah. Cool.
I didn't show the applications properties, but not much here. I'm just setting the dev service ports to some static ports for debugging purposes. And for Epicura registry, I'm going to auto-register the schema. We are going to see as soon as we push to Kafka, it will be the schema will be registered as an artifact. So back to my clicks resources. Let's see if the application works for now. So this is the index.html file served by default with the Quarkus application. And when I click, I can actually see that my XPath is pushed to the server, right? So let's push this to Kafka. And as we were saying from the beginning, in reactive messaging, when you're producing something, when you're consuming something, and processing something, some message, it goes through the channels, right? So what I'm going to define here is a channel and inject it with at channel annotation. And what I have is an emitter interface which will let me produce messages through this interface. So this will be an outgoing, so a producer channel. And my emitter, I'm going to use it by simply sending the click that I received through the REST endpoint. And because this is REST easy reactive, I want to make sure that this actually will be returned after that I know that my message, my record to Kafka is sent.
So
I'm going to
basically, it will produce a value when the message has been acknowledged by the broker.
Yeah. So let's see if, again, this is one of the great parts of dev mode in Quarkus is I haven't refreshed anything and it continued to work. And let's see if the message is delivering. So I have the topic. I'm using conductor to see the Kafka instance broker, and I have a topic named click. And let's see from the beginning. I can see that the messages are sent to Kafka, and I also know that a peculiar registry has registered the RO schema for me. And let's see right now that if we can consume the events that are sent. Do you have a question, Max?
No. I just yes, the conductor and is that all peculiar or?
No, not at all. Not at all. It's just another. Well, it's an UI-based client for Kafka protocol. So,
Got it. Okay. Got it.
Yeah. So
and
you can see your brokers.
Something that would make Max very happy is that we plan in 2022 to get some kind of API inside the dev UI. So cool. It's coming. So it will be all in the dev UI.
Got it.
So right now in the dev UI, all we have is the config editor, and actually you can see the channels for the reactive messaging. So I can see that it's an emitter that I'm using, which is auto-configured for SmallRye Kafka connector. And also it detected that it will use our Kafka serializer to serialize the records. Right. So let's go back to my application. I'm going to create a consumer clicks, let's say processor. And this will be an application scoped bean. And so when consuming events, again, I am starting by defining a channel. This time it's an incoming channel because I want to consume the events. One thing to note is channel names are unique in the application, so I need a different channel name. And I'm going to use this channel to annotate my processor method. Process clicks, and to receive a click, which I haven't shown you, but Quarkus generated the arrow from the arrow schema generated to be informing.
So it's automatic. We do it at build time for you. So as soon as you have an arrow file, you're done.
Very nice.
And I'm going to start by logging the, let's see, received. So So one thing to do maybe is by default for Kafka connector, the channel name is the topic that we are consuming or producing to. So now I need to make sure that for the producing part, I know that it will be pushed to channel the topic click, and I need to make sure that my other channel, the clicks in, is pointing to the right topic. So I'm going to configure reactive messaging incoming clicks in topic to click. And one addition that we had recently, I don't remember the version, I'm guessing that it should be 2.5, is the auto configuration of all these channels. So in build time, we know that you have only one connector for reactive messaging. In this case, it's the small I Kafka. And all the channels are auto configured for that connector. If not, I would have something like messaging incoming, like this one.
Why are you actually getting yellow lines in these things? Aren't they? These are not Quarkus configuration? No.
Normally, yes, but I'm guessing that in the autocomplete plugin, there's something missing.
Yeah.
It's coming. Initially, we didn't expose this, and because now we do the wiring at build time, we also expose the right build item. So this will be picked up as soon as there is an update of the tooling.
I'm thinking that most of the things are picked up, but maybe some of the channels we may need to fix something there.
Yeah.
Let's see. So I configured my clicks in channel to consume the click topic, and let's see when I produce some events.
Note that you don't have to configure the serializer or deserializer. Quarkus analyze your code and decide what it is, what it needs. Of course, if you configure it, it will use what you said, but most of the time, Quarkus will find the right one for you, and you don't have to do anything.
Yeah. Actually, we can check what it configured here.
Yeah.
Wow, okay. That was unexpected. I guess it's run the test, right?
Yeah.
Yeah. Which I haven't developed anything. So again, for the clicks in channel, the topic is click. It's detected that it will use the Avro Kafka deserializer from Epicurio. And for the producer channel, same thing, but for the serializer. So let's
just be clear, like in most applications, you would have these in two different apps, right? One is producing and one is sending.
Exactly.
Yeah, there is almost no use case of
writing
one, except if you want a safe backup or something like that. But most of the time you don't need this.
Sure.
Yeah.
Which is why you need to add this extra properties that say, oh, I want to read the click topic from the clicks in channels. Most of the time you don't need that because it's two different applications. So they can both be named click.
Exactly. Yeah.
Exactly. So now I know that we have the received clicks inside my processor, and maybe now I can do something more interesting and go ahead and persist some the records that I'm receiving here. And for that, I'm going to use the Hibernate extension with Panache. And for that, I'm going to add extension Hibernate ORM Panache. And as for the database, I'm going to use Postgres and GDBC Postgres. Hopefully, I got the extension named right. Yeah. So that added a couple of two extensions to my pom.xml, and now I'm going to create a DTO object because our schemas generated me a click, but I can't really use that to persist into the database. And
yeah, don't do that, because Avro or Protobuf, they add a lot of finals, generic things. So don't write that directly to your database. That's generally not what you want.
So I have that already prepared. I don't want to type all of this. Table. So I'm using Panache and creating a click DTO with an active records paradigm. So I have the user ID and XPath, and I can create a DTO and then persist it inside my application. And I want to have the table created as clicks. And let's see, in my processor, I can go ahead and create a new click DTO and process it. And that's it. More or less. Just before that, let me configure also the Quarkus data source dev services to the Postgres so that I can go ahead and check the database easily. And
so my brain, my Hibernate brain just goes like, we should have to do this better, shouldn't we? For the Avro, like Avro has a whole protocol. We should be able to actually create mappings for Hibernate.
Oh, yes, definitely. It's something we can do, but we're more or less looking at that from all these protocols like Protobuf, Avro, Swift, and so on. They all follow the same thing. So maybe that's the layer we want to integrate to do
exactly.
the right thing.
Yeah.
But anyway, it's cool.
Yeah, so I was doing the persists, except that the Hibernate needs a transaction, needs the persistence to happen in a transaction. So it's an update, and I need to add a transactional annotation to my method. Also, because it's a transactional method, I need to delegate that into a worker thread. If not, the persist is a blocking call. And all this happens inside the event loop, and I will block my event loop, which is not something that we want inside Quarkus.
And Quarkus will even complain, right, if you don't do the blocking. Right.
Actually, let's try it. So now it's spinning up the Postgres.
Boom! It complains.
Yeah, this is the fun way where reactive meets blocking. We had a lot of conversation back and forth. What would be the approach? Should it all be non-blocking by default or not? But we ended up in a situation where we are, how to describe best? We are looking at the signature and the use case you're doing it in, and that decides whether it's one or the other. So here, the default will be, because it has an income annotation, it's going to be non-blocking, and therefore you will have to tell, hey, I'm actually going to call something that's blocking inside. And yeah, we had all kind of ideas of, well, if you detect this blocking, let's just move it somewhere, but it becomes hard. So now we fail early and but default to what's most likely what you want to have.
I've started a pull request, well, at least a branch, where if you have an incoming which is annotated with that transactional, then if you didn't have ad blocking, I will add it for you. Basically, it's the only thing it does.
Yeah.
It will just add the ad blocking annotations directly. Okay. But it's not yet ready. I need to write the test. But who cares about tests, right?
What if you're using? Would that change if you're using Hibernate Reactive? Would that still be?
Well, in that case, it won't be transactional. It will be a reactive transactional. So we're good.
Got it. Yes. Yeah.
I will have an example on that later.
Cool.
So now we see that the click is persisted through Hibernate, and let's see if I have that on my table. There you go. Okay, I'm good to go to the next one. Let's see if we can, now we consume the click. Let's see if we can combine it to process so we receive the click, we persist it into database, and let's see if we can integrate that with a different connector. Now I'm going to use the HTTP connector that Clement mentioned earlier. And Quarkus extension add reactive HTTP. This is not standard small I, but it is a Quarkus extension, and it will let me use WebSockets and HTTP through reactive messaging.
And it's not in small I because it's based on the HTTP model and WebSocket model of Quarkus.
Yeah.
So it's really specific to Quarkus.
My method that consumed the event, I'm going to transform that into a processor method. So it will receive the click, do something, and then return it back. Let's turn back the click VTO. Right. Click VTO. And again, I need to configure, now that I have two connectors in my class path, I need to configure all the connectors, not this one, to use the connector that I want. So let's start with the outgoing clicks. So this is the autocomplete. And for the producer one.
Just was the connector small right Kafka, was that actually required before now?
No, because we only add one on the class path, so it will automatically attach any orphans channel to that one.
Okay.
But now that we have more than one, we need to help him and say, where do you want to read from and write to?
Yeah, what I was because when you put it first, I was like, why do you need that one? But okay, but now you do.
Not really, yeah. So now I do. This is the producer of the original click. This is the consumer one, and this is the one that we are pushing to the to a webhook. So cool. I found this awesome website that lets me test the webhooks. I'm going to paste the link so that I won't be creating a different endpoint in my application. And
so in addition to observing users' behavior, we're also sending that behavior to some unknown website. So yeah, everything fine.
Very GDPR compliant.
Okay.
Yeah. Well, you did consent to that by clicking to the accept cookie.
Sounds good.
So let me see. Oh, I guess I need to restart
I made a Disney import somewhere.
Yeah.
There we go. I must say, like, it's fun to look at because it's been a while since I've done it. I'm amazed how little code this actually is.
Yeah.
So.
Yeah, in a couple of lines of code, we produced event, consumed it back, and now we are sending to a third party. And let's see. Again, the clicks are sent, and I can see that the webhook is called as well with the persistent ID. So I have the ID generated by Hive.
What are we looking at now? It's a bit small.
So,
I can't see.
Oh, sorry.
You're sending to the webhook.
Yeah,
got it.
Exactly.
Recorder thing. Yeah, got it.
Yeah. So all this happens through again the fact that we are the thread which is used to send the events is the event loop. So we won't be using a lot of threads there, but we have the blocking annotation here because we are using the Hibernate, classic Hibernate with Panache. And now let's change it to Hibernate Reactive and get rid of that worker threads that we are creating and using. For that, I'm going to not use the the Quarkus CLI, but just
no, because you can't, because you cannot replace an extension with the Quarkus CLI.
Exactly.
You can add, you can remove, but you cannot replace.
But so I replaced the Hibernate Reactive Hibernate panache with Hibernate Reactive panache, and GDBC client, Postgres client with Reactive Postgres client. And now, well, actually, I can refresh my IDE. I guess I need to change the, exactly, the panache entity is not the same. I'm going to import the correct one, which has the Hibernate Reactive. Now, as for my processor, I won't be needing transactional or blocking, but now I need to, well, just observe that the persist now returns a uni, which is a continuation from mutiny. And now I need to return back to turn the uni back to my outgoing channel. So this processor method will be returning a uni this time. Except that again, I need to handle the transactional aspect of Hibernate Reactive. So I'm going to wrap that into a with transaction, which will open and close the transaction for me.
So this all comes down to, because you're doing reactive, the boundaries are not as, well, they're still clear, but they're just not easy to do in lines of code.
Well, we have the @reactive transaction or reactive transactional. I can't remember the name of the annotations.
I can't remember neither.
Yeah, but I'm not sure it works in. I think it's right now limited to REST easy reactive. I need to have a look at that.
Where does just my brain needs to remember, when does this transaction actually starts and begin? It's not necessarily before this transaction could start after I return this uni, right?
Yeah.
So it will be done probably, but not until this method returns. Transaction could still be in the queue, then it gets executed, and once it's done, then it will return it, and then the next in the chain will get it.
And to make it even more confusing for you, it may not have started when this method returned, because it will only start when it gets an item. So after the subscription, it will get an item, and then it will start the transaction.
Ah. Okay. Fun.
Now at least I think this should be logged after I persist the click, right?
Yep.
So this is
well, invoke would have worked, but yeah.
Yeah, I know, but I think the nested methods helps a lot on understanding what's being done. And let's see. Now I should observe that the persisted click should be called inside the event loop itself. I think it restarts all these services. No, but curious takes some time.
Yeah.
There. And the persistent click is
From the
one in the event loop, exactly. And let's see now if we can jump to some other topic. Well, one thing that I'm not good at is writing the front end code, and I noticed that there's a bug in my code. Let's see if you can get that. Actually, sometimes I'm creating an animation with the with an element, yeah, with the click, and there you go. And I have this. The animation itself is logged actually. So I want to make sure that in my backend I correct that and not log this, right? And to do that, well, let's see if I can extract that in my purchased method. And I'm going to validate basically to say that in the XPath, if it equals to this thing, I'm going to throw an exception. Animation click. And yeah, let's see what happens in here. So I'm basically rejecting the record by throwing an exception, right? Before the persistence.
Yeah.
Let's see. Oh, okay. I didn't expect that much of a. Actually, why it quit. I don't know why it quit the application, but let's see. It's being restarted. So now it's we can have that edge case, which happened fairly easily before. Let me see.
Well, now you have the whole streaming, so maybe it doesn't get caught.
Oh, maybe, yeah. Let me see. That's annoying. Yeah, there we go. So what we have is once our reactive messaging process had an exception, the default case is that it's fail stops and stops processing the events. The application is not quit, but that stream is closed, so we won't be having any messages to that channel.
Yeah, so it's just the message that has the click in it will get. Yeah. So scenario.
So to correct that, we propose the failure strategies inside.
Okay.
So the
property name is too long. That's the problem.
I think so. Yeah. So the default one is I don't remember the default one. The name of the default one. Do you remember it?
I think it's fail fast.
Fail fast. Yeah. Right. So now I nailed it down to ignore.
So obviously we have more than fail and ignore. We have DLQ and things like that.
Yeah, I think ignore is a for this use case it's enough, but we can have the as you said, the dead letter queue.
Yeah.
Which will create a different topic in Kafka and push events to that one. I think because we are processing the events from the earliest, we should see that.
So we still get the error where it happens, but then
the processing
application continues. Yes.
Yeah.
And actually, we have a log saying that it will be sent to this topic.
Yeah.
And I can observe that.
We got a question about some of this.
Yep.
Okay.
It says, so Kevin Viet says, Kafka processes the record in batch.
Mm-hmm.
Kafka processes the record in batch. I'm wondering how you manage to offset commit in a reactive, maybe this more asynchronous world when involving the transaction.
So by default, what we do is that we get the batch. That's okay. We tracked all the offsets, and we have throttle commit strategies that will commit actually an offset when we have a sequence of records that have been successfully processed. So if you let's imagine you process your records in a completely serialized manner. Then there is no problem. After 5 seconds, I think it's something configurable. We will commit where we are. Things are a lot more interesting when you do asynchronous processing because you may have holes in your things. So we can only commit all the consecutive offsets records, but as soon as you have a hole, we can't commit anymore. If we commit further, then we ignore the fact that this was not managed properly or even maybe failed or something like that. So the throttle commit strategy as a way to detect that. And you can extend the time. You can do a lot of things to avoid the poison pills. But yes, so that's exactly this. That's the commit strategy throttled, which is the default. We have the latest, which should not be used, but is still there, which basically commit as soon as we have an acknowledgement.
Like the don't care approach?
Yeah, it doesn't care. You get a message acknowledged, it will commit the position, even if
there's holes.
We also have ignore, which means that we are not going to commit the offset. So maybe you do it manually because you can do that, or you have Kafka doing that for you using the auto commit. However, be very, very careful using auto commit. It can introduce a lot of bad things for your applications. So we heavily recommend the default, which is throttled, which is doing what I just said. I've wrote a blog post about when to commit Kafka, when to commit something like that on Quarkus a few months ago, which covers the different cases.
All right. So the summary is that this is this is always a challenge because we do an async processing of a channel. But the good thing is that because it's in the framework, it can keep a track on everything. But you still have to be mindful of what you're doing, which you would have to do even if the framework wasn't there, right? If you started.
Yeah, exactly. The worst thing that can happen is that you forget to acknowledge or to commit, to acknowledge a message, which means that you will have a hole forever, which means that we can't commit. And because we can't commit, we cannot make progress. That's what we call a poison pill. So the throttle strategy has some timeout in place to detect that and tell you, hey, that offset, something pretty bad happened for that offset because we didn't have an acknowledgement after, I don't know, 1 minute or something like that. So something is definitely wrong.
Cool. Yeah, and if you didn't use reactive messaging or something like this, you would just never know until you go back and look in the logs, I guess.
Yeah, and if you want to implement the throttle strategy yourself, good luck, because Ozan had a lot of fun with it.
Yeah.
Cool.
It is originally a contribution from someone, I guess. Now.
Yeah. Okay, we about the hour. Do you have anything else, Ozan?
Well, I have a bunch of things. What I left is to show you guys how we can consume the batch of messages. But
that sounds
it involves
just in time.
Instead of reading them one by one, you can actually read them by batch, because that's what Kafka sent to you. Something to keep in mind while Ozan is writing the code is that we implement a back pressure protocol based on that. So basically, we resolve the batch, and according to the amount of the capabilities of your applications to consume, the amount of requests in reactive lingo, we will pause the topics or not. So pause doesn't mean that we don't call poll. Be careful. We still call poll, but we have paused the topic. So there is some operation like this that we do for you. So your application don't break the Kafka protocol and still have back pressure.
Okay.
Well, it's fairly difficult to write
That's actually something I need to write about, a blog post about that. That's I think I didn't.
Let's see.
So instead of having a individual click, you can just get a list of click, which will be your batch. You can also use consumer records, which is a Kafka type for this batch of records.
And let's see if we can return this.
So just I get it right. So this is Kafka still sends individual messages, but we just consume them in batch, or is it all?
Yeah, we get a batch, and you get the full batch inside your method.
Okay.
Be aware that batch are generally associated to your partitions, so that means that it's a batch of a single partition or two partitions, depends on how many partitions are assigned to that consumer. But yeah, it's they don't mix up.
Let me see if I'm getting everything correctly.
Hey, Fluent program should be easier, right?
Yeah. So this returns a Panache entity that I know. Well, actually, I know what's happening here. Yeah.
You cast the persist after.
I can cast the persist in here. Yeah.
No, it's a uni of click DTO. It's not a click DTO.
Yeah, but it won't work on cast now. So what I'm interested in is how many things that I'm trying to commit, right? So
there you go.
There we go. And it's that much of clicks. So not what I did here is for each of the clicks, I created the DTO and persisted them inside one transaction. Actually, there's a better way of doing that, but it involves writing a small bit of SQL and using the underlying Postgres client, which has an execute batch. Yeah. And I think that this should work, but to be able to see it, I think we are going to need to configure the batch mode for the Kafka underlying Kafka client.
Oh yeah, because by default it's 500, so you will need you will have to click a lot.
Not only that, but the consumer consumer has these fetch min bytes and waits. What was it? Fetch wait max wait milliseconds, I guess. So let's create these ones. And actually, the consumer now will wait for 3 seconds to fill up the batch, and as soon as it has like 1 kilobytes of messages there, it will trigger the batch. So okay. I should see that I will be having we are processing the clicks all together, which is a common use case from what we saw from questions.
So so you get batch of things and you want to persist all of them in one go. So you will not do like this. You will use a proper API that allows batch
exactly.
writes.
Don't do that.
But it's when you have Kafka or something like that, you generally have lots of messages and you want to batch them, and write one by one will be too slow. So you want to batch them, and you will do something like this.
Cool. Okay. Well, you talk about hour. Do you have more, or you want to do a second one?
I have one last thing, but I'm not going to code it because it involves Kafka Streams API. I'm not that fluent in that. I coded earlier, but I can comment on the code. So the idea was to let's see if I refresh that. So I've added the Kafka Streams extension, which we propose and wrap the Kafka Streams API, and it's easier to use with Quarkus that way. So what you do is to produce a topology of Kafka Streams, And the Kafka Streams builder is created. The Kafka Streams application, in that sense, is created and configured automatically by the extension. So all you have to do is to create the topology and produce it as a bean, as a CDI bean. In here, I have configured the Avro Saturday for the Kafka Streams API for it to use the correct artifact ID. And maybe there's a better way of that, but that's all I was able to get it to work correctly. And then I'm consuming these clicks. I'm grouping them by the XPath and counting how many clicks have been done into one element. And I'm pushing them back to Kafka into clicks per element topic. And then I'm creating a different reactive streams channel, which is consuming the clicks per element. And this time it will push them through the server-side events using REST Easy Reactive. So it's pretty easy to do comparing to using the server-side events API. You just have to return the Mutiny multi reactive stream back to the REST Easy Reactive. And you can actually chain processing methods into that channel. And what it does is when users are clicking away in the application, let's see if the application still survives, and maybe not. And when the users are clicking away in the application, we are trying to trace which element is clicked the most, and try to create a kind of a heat map of elements clicked, right? And let's see if everything is configured. So these are the logs from Kafka Streams API application. And I'm sending some clicks into the application, and I should see that. Oh, 8080, and I have a flag in the application to just visualize the clicks and the heat map. Let's see if it works. Maybe not. Do I have any? Oh, there we go.
Oh, cool.
I was actually showing the right pane. So that's the advantage of using the reactive messaging and Kafka Streams. You can have your aggregation logic in Kafka Streams API and externalize it into a different messaging backend or different integrated REST Easy Reactive, Hibernate Reactive, using reactive messaging APIs.
Very nice. Very nice.
So that's all of it from me, I guess. Let's see if you have any questions.
Yeah, we don't have any extra questions in the chat yet. And we are like 10 minutes over. So, yeah, unless you have any final points you want to address, I think we can adjourn.
That's good. Well, one thing I wanted to ask. We added this Kafka UI thing.
Kafka Streams UI. So the
yes,
UI has a Kafka Streams topology viewer. Yes.
Got it. Okay. Different.
Yeah, we don't have. Well, actually, I think Martin was contemplating the idea of doing something similar for reactive messaging, unrelated to Kafka, but really showing the graph. Because we now expose the data at build time, so we could generate SVG or dot at build time, and so you can have it, you can see it. But yeah, well, have not done it because we are pretty bad at styling things. So if we do it, it's going to be ugly. And so, but things are done. So it's actually something we have done recently. That the extension is now doing a lot more work at build time to report a lot more issues and compute things at build time, which is more the Quarkus way of doing it. And it has benefits on your runtime a lot, including memory, startup, and things like that.
Yeah.
Cool. And do you guys do more validation, or is it more?
I do a lot more validation. I check that your graph is consistent, that you don't have things not bind altogether. So I can actually eliminate part of your graph directly. Because if I see that there is things that are not used, then I can just remove them and things like that. So it's the beginning, it's the first step. I have more ideas of where we can go with that. But
Well,
yeah, it's already
people with computer science PhDs always love working with graphs, right?
Exactly, and you have two there, so imagine the graph at the end.
Awesome. Well, thank you, Ozan. This was good. I learned a few
Thank you,
things. So that's nice.
Very nice.
Okay. Well, we'll sign off. No other questions. And thank you.